Well, first, congratulations everyone for making it to the end of the conference. And I've heard two people telling me that they're here right now because of my talk, and since it's more than one, I'm gonna assume that's the case for everyone here. So, thank you. Yeah, thanks for the introduction. So, my name is Yiping, I'm a postdoc at UMich. I mainly work with Professor Jason Mars and Ninja Tang. Today I'm super excited to share with you this work that we've been doing that look at, there's a lot of work today that look at how we go big, right? Tom Winnish earlier talking about 100,000 GPU training. I thought to end the conference, I can talk about a little bit about how we go small, right? So specifically, we've been looking at a lot of open source small language model, or we call SLMs, and how they compare against OpenAI's LLM, right? And I'll start by saying, this is, some of you might not think this is a apples to apples comparison. We are comparing against self-hosting model with OpenAI's API. But from a developer's perspective, that's kind of the best we can do because we don't really know what they have going on under the hood. Nonetheless, I think some of the insights hopefully are interesting. So, we're all familiar with this, right? Alicia literally said the word earlier. Generative AI is taking over the world by storm, and this is a trend that's been happening with AI technology for the past almost decade. But one thing that's different this time is how fast industries are adopting this new technology, right? If we look at convolutional neural network and LSTM and all that, it took a while for really industry to start adopting it in any real serious way. But with LLM, startups and enterprise jump on that bandwagon in no time, right? Even some of the industry that are notoriously for slowly adopting technologies, such as the financial sector, are jumping on the LLM sort of train. So, a lot of companies are trying to build their features using generative AI and use large language model. And over time, sort of using these commercially available API have slowly become the go-to options, right? And through all of that, OpenAI's GPT-4 has sort of become this de facto option. If you want to build something with LLM, you go OpenAI, you go GPT-4, you get the best sort of capability. You might feel like I'm picking on OpenAI. There are other options out there, and some of the insights will hold for these other commercial options as well. So, there's no it's no surprise that something like GPT-4 became the de facto option. There's a number of benefits, especially from a software developer, AI developer perspective. First is these models do have the sort of state-of-the-art cutting-edge capability. And two, because they're setting the API, the developer interface is very friendly. And as a result, it's very easy to get something up and running. So if your goal is to prototype something really quick or iterate something really quick to push a solution to the market for your customer, using this API is really a great place to start. But once you get past that prototyping stage, once you start thinking about serving users in production at scale, a number of problems starts to pop up when you're using these proprietary APIs. First is personally have seen, and it's echoed by the community at large, that these APIs have very inconsistent latency. And sometimes they have very long tail, right? And that will really hurt sort of the end user experience. And in addition to this, because of how these sort of APIs are structured, oftentimes there is a rate limit on the client side. So you have to, as a developer, you have to manually limit the rate at which you can send the request. So especially if you're serving at scale with lots of users, you end up having to sort of back off and wait and end up with a long tail yourself, even if the system on the other hand is actually doing okay. And then there has been more than expected sort of unpredicted outages of these systems, and obviously that's not great. And then cost is really sort of the issue here. So the way that these APIs are structured, and this is not only with OpenAI, the way that they charge is by token, so per input token, per output token. And those can really add up, right? So from our personal experience, we build features that sometimes can cost something like 13, 14 cents per request, right? And that's a lot. And that has improved recently, but overall cost is still sort of a pretty big issue here. And from a developer's perspective, you often end up with this sort of dilemma where you're conscientious of cost, but at the same time, you want to build the best feature, you want to build the best experience. So you end up in this like sort of rock and hard place, and that's not great to be at when you're an AI developer. And then the other sort of inherent limitation of these proprietary models that are hidden behind the API wall is it really limits what you can do on customization, fine-tuning, and personalization. So while there's this limitation of these proprietary models, really over the last sort of year, there has been a swath of open source language models, or specifically smaller language models that popped up and really gained a lot of popularity. And really a lot of these are kickstarted by Meta's open source of the Llama architecture, right? Some of them big names and Mistral, Zephyr, they're all built on the Llama architecture. So really, a lot of credits of this initiative have to, be given to Meta. But nonetheless, like there's this whole host of open source models that are being released every month, and they're showing, at least on paper, from a benchmark perspective, very competitive performance compared to these larger models. And then, on top of that, thanks to various very mature quantization technique, we're actually able to bring these already pretty small model to be even smaller with very small accuracy loss. So when we have this sort of dichotomy, we kind of ask ourselves, can we replace these proprietary LLM APIs that are expensive, that have all these limitations when it comes to serving at scale in production? Can we replace them with self-hosting these small language models ourselves? And I highlight the in-production piece here because this is really sort of the key that the thread that kind of chained together some of the study results you're going to see. Really, we focus on when you're trying to serve people at scale, user at scale, can we replace, right? Are these self-hosted SLMs ready enough to replace sort of the go-to option like OpenAI? But in order to answer that question, that's not actually one question. There's actually a multiple facet to that question that we'll have to answer in order to answer the main question. First is, and the most important thing is, are the quality of these SLMs, meaning the quality of the response they generate, are they good enough for serving real users? So in this work, we sort of focus on use cases where the output generated by the LLM are sent directly to the user. So think about chatbot, virtual assistants, or QA system. So are these response generated by these models, are they going to be good enough to put in front of your customer if you're a company? And then what are the latency sort of implication and trade-off of hosting these models yourself, either in your own stack or in something like AWS, versus using these readily available API that are obviously backed by much more powerful compute that most people would get their hands on? So what are the latency trade-offs? And then related to that, what are the cost trade-offs, right? Is it cheaper? Is it more expensive? In the short term, in the long run, what does it all look like? So because we have to answer all these questions, what we realize is what we really need is a systematic methodology and a set of tooling that can help us characterize and evaluate these SLM, small language models, for production use cases. And so far, we don't really have such methodology or such tooling available. And that's where this work kicks in. So for the rest of the talk, I'm gonna spend the next couple minutes talking about SLAM. So that's the open source tooling that we built, that we released to help evaluating SLMs. And then I'm gonna take you on a journey of how we apply SLAM on a real in-production application and a real in-production feature, how we apply SLAM to find the right SLMs for that feature that we were building. And then along the way, I'll share a couple of results and insights. Some are expected, some are perhaps counterintuitive. Okay, so SLAM, pretty basic name, small language model evaluation platform. And what it is a systematic methodology for evaluating open source SLMs compared to proprietary LLM APIs. So for this work, we focus on OpenAI, but really the methodology and tooling applies to all the other options like out there. And we characterize three main aspects: the generated performance, meaning the quality of the response, the latency performance, the request latency performance, and the cost associated with it. And then we employ a human-in-the-loop sort of testing process with automated evaluation technique whenever possible. So I'll go into a little bit detail there in a little bit. The tool itself is generalized and agnostic to any LLM feature, as long as the feature is done through prompt engineering and putting input to the LLM. And we have out-of-box integration with various LLM APIs out there, as well as a huge set of open source LLMs and SLMs. And it's open source. So this shows an architectural overview of the various SLAM components. A lot of details are in the paper. So I'm going to highlight sort of three things in this piece. The first is the one on the left, where the tool will actually take care of the acquisition and hosting and inference integration of the SLMs that you want to evaluate. So you don't have to worry about sort of figuring out how certain library works and you put it up into your code base and all that. All that's taken care of by the tool. And then in the middle piece, that's really sort of the meat and potato of this tool is where we conduct the evaluation from those three aspects for those SLM: quality, performance, and the cost estimate. And then and all these evaluations are then fed into a dashboard. So the tool has a UI where you can you can check out the results of these three aspects in various different visualization. So there's a lot of sort of design choices that we made with these two. I'm not going to go through all of them. I'm going to focus on sort of two components and some of the design decisions that we made that might be interesting to this community. So first is the human evaluation piece. So we decided to, at the end of the day, rely on human as sort of the ultimate judge of whether the quality of the response are good enough, right? There are work out there that are trying to use automated evaluation to replace human, which we will do a little bit. But ultimately, we found that sort of because the response are eventually are going to the user, we want human to be the final decision making that decides whether the model is good enough or not. But with any sort of human sort of preference evaluation, there is a challenge of how do you get reliable and representative results from human, right? Different people have different preferences, depending on who, the pool of evaluator, you might get different type of results. So we have this human evaluation component that there's a number of sort of neat techniques that we put in here to help address this challenge. First is that we sample multiple responses per model, even for the same input. So as some of you know, LLM does have or generative AI in general has a variance from run to run, you might get different results. So we made sure to sample multiple responses to get a representative results from each model. And then the results are then anonymized and randomized randomized in the sequence that they are presented to the evaluator, and then they're blind to the evaluator in the sense that as a human evaluator, you only see the response, you don't see where which model generated to avoid any bias. And then the human survey are automatically generated with a set of carefully designed and tested template. So, if any of you have used crowdsource before, you know that crowdsource has, there's benefit, you get results quick for cheap, but sometimes the results might not be reliable because you're dealing with public crowd. So we've had experience in dealing with that in a previous slide. So we've incorporated a number of techniques in a survey that the tool will generate to make sure that the results we get is reliable and representative as much as possible. And also the tool is flexible in that you can use it both for crowdsource as well as internal domain experts. So let's say your use case is super specialized and you have a designated pool that people that you want to use for evaluating, you can do that as well. So that's the human evaluation piece. Even though we rely on human evaluation as sort of the final decision maker, human evaluation can be time consuming and potentially high cost, right? Especially if you're trying to iterate quickly, push something out, you might not always have time to run through a whole host of human evaluation. So then, we want to incorporate automatic evaluation technique to help reduce the human evaluation time and cost. I can see I'm running over time, so I'm going to kind of quickly cover this. So we have a set of automated evaluation techniques. There's two main types. One is we're using we're actually bootstrapping and use LLM as an evaluator. So treat it as a human, give it instruction to ask it to evaluate the quality of the response. And on the other hand, we also have a set of semantic similarity-based scoring. So this is for use case where if you have a reference response that you really like, we then rank the model's quality based on how closely they resemble the response, the reference response. So we go into a lot of details on how these automated evaluation sort of trends align with human. The sort of TLDR here is what we found is you still have to rely on humans. So automated evaluation are not yet ready to completely replace human, yet it is helpful at identifying sort of the clearly best model or clearly worst model. So it can help you reduce the pool of models that you want to consider so that you can invest the human effort in a really focused way. Okay, so I'm gonna go a little bit even quicker for the rest of the talk because I'm over time. So now I'm gonna talk about sort of the case study. It was really important for us to test this on a in-production application with the in-production feature. So what we did is we conducted a case study on this application that I'm actually a co-founder of with a number of other folks from AI. What it is a personal productivity platform. So to put it in a little bit more plain, is think about to-do list, but supercharged with AI technique that help you maximize your productivity, manage your life better, make you happier in general. And one of the key features that we recently introduced is this, what we call daily pep talk. So basically what it is a encouraging message that when you start your day, this system, the bottom right, will give you an encouraging message that kind of summarize what you did yesterday, give you a preview of what you're coming up today, and maybe rally you up a little bit, right? I think if you have a personal assistant, the first thing he or she will say to you when you walk into the office. So we built this feature, the first version with GPT-4, we released to the customer, it was received really well. But very soon after release, those issues that I mentioned earlier starts to show up. We're starting to see very inconsistent latency, requests being dropped, and we're seeing costs were adding up very quickly. So then we applied SLAM and we went on this journey to answer the question for ourselves. Can we use some of the open source model for this? So we looked at 10 of the best, or at the time, most popular SLMs. And then we mainly focused on the 7 billion and 3 billion parameter variation because of their size. And for some of these models, those are really sort of sweet spot in terms of among their variation in terms of performance to computation trade-off. We also looked at the quantized version of these models, right? For really sort of efficient and small model to look at. So in total, we looked at 29 unique models. And these, for the self-hosting setup, these are hosting AWS instance with a T4 GPU, so nothing crazy. And we're comparing them against OpenAI GPT-4. So what are the interesting we learned, right? So go back to the 3 questions that we wanted to answer. The first one is, are quality of these SLMs good enough for production? So here what we show is the human evaluation score. So think of, from 0 to 10, the higher the better. 10 being human think this is the best response ever. So what we have on the left is GPT-4, and each model, score for each model is represented in a distribution because different human has different preferences. So one thing we're already seeing is, there are a variation in terms of which is among human preferences. So that's something we're actually digging into in a follow-up work. But if you focus on the red line in the middle, which shows sort of the mean human evaluation score for each model, with GPT-4 on the left, what we found is many SLMs are indeed competitive in the quality of the response from a human preference perspective. And specifically, these 2 models that I'm highlighting came really close to the human evaluation score that GPT-4 is receiving. And one of them is even a context model. Right, so this is really sort of exciting news to affirm sort of some of the results, some of the benchmark side of results, and affirm it in a human evaluation way that these SLMs are indeed good enough for serving in production. Then let's take a look at latency. So here what we're showing is the latency, the single request latency of GPT-4 combined with all these other open source language models, GPT-4 being the one on the top. Well, we noticed two things here. One is these models are the small language models when we're hosting ourselves on the machine that I mentioned. They generally sort of perform similar or slower in terms of request latency compared to hitting the API directly. And the other thing we noticed that are a little surprising is some of these SLMs have very wide latency distribution. Keep in mind that this is result from the same input. So we were a little surprised to see that such wide distribution for same input, same model, just from run to run. So we dig into it a little bit. One thing, sort of Alicia mentioned a little bit earlier as well, generative AI performance correlates with the number of tokens that it generates. So the way it works, you generate the first token or the first pixel, and then the next one, the next one, next one. So in a way, single request performance sort of correlates with the number of tokens that you generate. So when we look at that, the number of generated tokens per request for each one of these models, we notice that some of these models just generally are all over the place when it comes to the number of tokens it generates from run to run. And this is from the same input. But if we take that variable out of the way and we focus on single token generation latency, what we found out is that some of these models are similar or even faster than hitting the OpenAI API. And keep in mind, this is on the T4 GPU. So if you give a better machine, it can go even faster. So this is definitely one of the interesting things that we found, that while these models are faster from a single token perspective, the fact that they're very inconsistent in following the directions on generating the length of response that you desire present this sort of this interesting situation. I'm gonna skip this because of time and get to the cost piece. So we covered quality, we covered latency. The last sort of one of the three pillars is cost. So here we compare the cost of hosting these SLMs on our own machine versus hitting the OpenAI API. And the way that we evaluate is basically to sustain the same amount of throughput, what are the costs or the comparison between the machine cost versus the API cost of that are charged per usage. So we found out is, across the board, these models are generally much cheaper than hitting the GPT-4 API. We're looking at 5 times to even 29 as a cost reduction. So the SLMs are certainly very promising from a cost perspective. So the future of the project, right? So I'll just say a couple of words. This tool is open source. We encourage everyone to try it out. I think we focus on one use case for one hardware. So certainly some of these conclusions and insights are very specific to that setup. But what's exciting is that methodology is generalized, right? So we're excited to see what the community will do, both in the system and in the AI community, that can take this tool and applies all sorts of different problems that they may be trying to solve. And we're working on a couple of active follow-up work, right? One is we started to dig in on the human consensus and whether we can come up with some more impactful auto-evaluation technique that can eventually take human out of the loop for evaluating these models. And we have a whole host of roadmap of more community-focused tool that we plan to build and release. Skip conclusion, I mentioned one last thing. So the SLAM tool is developed on the JAX programming language. So this is the new programming language that we've been working on for some time now. We're almost done with it. Yeah, I think it has a lot of interesting sort of a relationship to some of the talks that happened today. Generally, we're trying to, at the programming language level, trying to bring data and compute closer. We're also exposing LLM and AI-specific language feature at the programming language level to help people build application easier. And this language supersede 100% of Python. So anything you can do in Python, you can do in this. So we're still working on this, trying to finish it up. But watch this space. This will be something that will come very soon. And thank you.
Questions from the audience? Thank you, great talk. So given all that you've now learned, what is the AI model that you are actually using in your application?
so some of them are still GPT-4, but there are a couple that are proving to be really useful. So Mistral is one that's really good. Zephyr is another one that have shown really promising performance. So yeah, we're sort of taking an approach where like for prototyping and building something to proof of concept to see if it works, we'll start with these APIs, and then once we get into production, we'll then switch to some of these open source models.
Okay, thank you. And then I have one more question actually. So this is more on the human reviewing side. About how many people do you think it would take to get like a reliable distinction which AI is better, A or B? And then if I were starting a company, how many dollars would I have to spend in order to set up this whole pipeline and converge on the best one? That's
a great question. So I'm gonna give you a long answer. So this is actually something that we're actively looking into. So one of the, if you remember I can put it up. If you remember the human evaluation graph, right? So what we saw is while there's this trend from model to model, within the same model, there's still a large sort of variation on human preference. This is not surprising because every human has their own bias, right? So really, how do we drive human evaluation process to get human consensus, and how strong is that consensus? It's honestly a sort of open question that we're doing some work on. But to kind of make it a little bit more practical, you don't need a lot of people, right? So for this study, I think we did, I forgot how many, but like it was less than 100. So it's you don't need a lot of people. You'll be able to get some insights from it. Yeah.
Okay. Any more questions? I will leave my question for you later offline to save some time.
Oh.
Yeah. Okay. Let's thank the speaker one more time.